Hey guys, welcome back to the shop. I have a couple of shafts that I need to make for the fab shop, so we're going to go ahead and knock this out. I have my lovely assistant out here today, Abby.
Hello.
She's going to be giving us a hand taking some video. She wanted to try it a little bit different this time, so we're going to give it a shot and see what kind of video we can get out of this. So we've got two shafts to make, 1 7/16 diameter, 57.5 inches long, and an 8-inch long keyway on both ends of the shaft. That is going to be a 3/8 wide keyway that we're going to make. The material is going to be 1018 cold rolled. I ordered the material yesterday from Alro. They delivered it first thing this morning at 7 o'clock. We got it on the saw ready to cut up. So what we'll do is we'll get our shafts cut. I'm going to bring them over to the 3-jaw and just chamfer them here. And then we're going to go over here to the KVC mill. We got to get a second vise set up. So we're going to use 2 vices that are parallel with each other and hold it, and it'd be a simple job. Mill key on it one end, flip it around 180, get it lined up, and then mill the key on the other end. So fairly simple routine job. So let's go ahead and get this one knocked out. All right, so it's not often that the metal suppliers make a mistake, but it has happened in the past. And this is something that I actually never remembered talking about in the video before. This was years ago when Dad and we had a bunch of large diameter shafts that we were making for a company. Big stuff like, 4 7/16 up to 6-inch kind of range. Well, one of them that they sent was the wrong diameter. And we already cut the shaft to the length it needed to be before we realized it was the wrong diameter. So another learning lesson, a really quick thing to do is whenever you get your material from your supplier, take your calipers and just verify that they did send you the right material. So we want 1 7/16. We got 1 7/16 right there. So that is just a very quick, easy way to verify that you have the right material before you cut it, and then it causes more problems because they said, oh, well, you should have checked that before you cut it. Now you got to pay for it. So anyway, I just wanted to give everybody a reminder of that. That's something that I try to always remember to do now because of that error that was made a while back, is just verifying our material size once it gets delivered. First thing I'm going to do is just cut the end off. These bars they're sheared at the factory, so they got a sort of a messed up end, so you really need to cut that end off before you get started. Just line it up, just get as little as possible. All right, we should be good to go. Coolant on. I swear the coolant on this saw, it like works half the time and half the time it doesn't. It is a little loud, isn't it? Yeah, I think I'm gonna put my my hearing plugs in my ears there because my ears don't like that loud screechy noise. I'm sure that it just needs coolant down there. It seems like it's one of the machines that it quickly evaporates, and you have to have this saw like topped all the way off, or else it starts starving itself for coolant every time. But we only got a couple little cuts to make. So here's what I'm talking about, that sheared end. You can see it messes up the actual true diameter of the shaft. So it's always best just to cut that little end off there. Dang, seems like it got tighter on me. It's almost to the door. All right, so I just want to verify my length again. 57.5 inches. Just butt it up against the blade there. .57 1/2. Just tighten it up. Verify it again. 57.5. So you don't do the, well, I cut it twice and it's still too short. Here, you plug it back in. That carbide blade, it makes some noise. A rag in my pocket. Why would there be? I think what we'll do is just go ahead and reverse it this time. Apparently I tightened it. I didn't want to tighten it. 57.5. And I oftentimes get paranoid that I'm still not right, so I like to just double check my notes. 57.5. That's good. A little bit of leftover stock right there. Right about there. That's good.
It's nice being in the shop when it's not so hot.
Yeah, it is. It is. I would actually love having the door open, but it is a rainy, humid day outside. And I like to try to keep it dry in the shop as much as I can. So I keep one of those units on dry mode just to keep the moisture out of the shop. But it looks like the rest of the week, I think it's gonna clear up. It's gonna get cold again down here in Florida. So I'm just gonna chamfer it in the lathe here. You do not have to do this. This is not a requirement. They don't ask for it. It's just something that I like to do. You can certainly take it right over there to the grinder or the belt sander, or just get your grinder out with a flat disc and dress it that way. Let's see here. That's 380. Nothing wrong with that at all. Just enough to break that edge off. Like that. Feel it? I'll go ahead and do it. Sometimes, even when you cut it, especially at that slower speed like that, it'll still try to roll just a slight edge over the top. Just take a file, just like that. I just pick up on that back end to help get it centered in the chuck. Me being a machinist and running a machine shop, I just prefer the cleaner chamfered look like that. It's a little bit more pro versus holding it up with your arms and trying to hit it on a belt sander. There we are. Just a few minutes on the lathe. You got a nice chamfered end. So from here we need to go over to our milling machine and get it set up. I'm going to get a second vise set up on it so we can hold these and get the Keyway milled. So we'll jump on that next. All right, we're going to set up to do these on our KBC milling machine today. I've already got, this vise is still trammed. We're going to set a second vise down here just to hold the shaft. And I've been asked this before. I explained it in the last Keyway cutting video. Why don't you just lay it down in the groove? That is the way that I've done these over the years. But the problem is this particular milling machine table, the 3 T-slots are not machined all the way across. So you can see that it's flat right here. All right, so if you have a long shaft that has to hang off, you can't clamp it down in this groove because you'd be bending it because it's going to be sticking up there. So that's why on this mill, you have to elevate it with vices or V-blocks or other fixtures, and you can't clamp it down. But that is a great way to do long shafts, is to, I would put a shaft in one, and I would just cut some little pieces like off that leftover stock we have to go back here, and I would use a strap clamp in a few places along there and hold it down. Great way to do some shaft Keyway cutting. I'm just gonna bring the table all the way down. I think we can reach it. I've got a vise there with the sky hook we'll use. Pick it up with that and set it over here on the table. I've already got a T-nut in there. I think we'll be able to reach it. I always like to give the tables and accessories a coating with the SP350 from CRC. Just a nice rust inhibitor and lubricator. All right. Let me just see if this is going to reach. I think that'll reach just fine right there. Make sure that we don't have any chips on the bottom. That seems so much more civilized than having to pick it up with my back muscles. Let me get this guy out of the way. It's almost time to go to the scrapyard again.
Yeah, it is.
I got one more can that's probably going to be full by the time we finish that batch of drill indexes over there, and we're going to have another haul to make.
I did get a note from someone asking if they could buy some of the chips.
Buy some of the chips.
From the drill index.
It's interesting. I've had people ask that over the years, and
we could like put it in like a mason jar or something.
Or a box, a cardboard box that we've invested in to ship all of our parts. All right, we're just getting this clean. This other, I'm just going to use the standard snap jaw there, which I've got in the drawer. These are really cool jaws. This company, Snap Jaws, all you guys probably know Snap Jaws, but they have a really wide variety now of different jaws that you can buy for 4-inch, 6-inch, and 8-inch vices. I try to get that bolt as close as I can, like that. This is the only part I really don't like, is having to get this this Allen key in that bolt. There it goes. All right, but we got it there. And we're just going to slide this guy all the way down to the end. I'm using these 1/2-inch studs here. And then we'll have a, actually, I need to use the 2 longer ones here. I like using these heavy-duty washers. You're on video, so everything's going to be,
of course,
not going to go as planned, you know. Let's spend a while getting the flange nut on there. This is showing what it really takes to do machine work. Everybody on Instagram and YouTube makes everything look like just absolute perfection, right? In reality, you're over here struggling to get a nut started on a stud. Okay. We do need to trim this in, so I will set up a, I think what I'll do is get a parallel. I've got a long parallel that we can clamp in here. Since this one's trimmed, I'll put one of my long parallels in here and then just tighten this vise up to the parallel and then snug the flange nuts down. The big parallel that I use for stuff like this, and then what you can do is we'll tighten this one.
That is pretty.
Pretty.
Yeah.
All right, and you see how it's gonna move because it's straightening up here. And then I want to make sure it's good and tight. And that should be nice and square. This is a big, heavy, you know, cast iron parallel right here. And then what I'll do now that these nuts are loose, we'll go ahead and tighten this up and it'll square itself up. Right there. Square itself up. Tighten it up. That should be nice and parallel. And I've actually inspected this before many times. When I've tightened up one of these heavy parallels and I would come down here and check this, I would be well within 1/1000th of an inch being in line and square and parallel with that. So us making an 8-inch keyway on one end, that's going to be fine right where it's at. That should be good. I'll get this big old heavy guy out of the way and then we'll get our shaft in there. We're going to set these right down in the bed of the vise. I'm going to hang this is our cutting end here, and I'm going to hang this off, you know, I don't know, a couple inches or so. Give just enough room we can get in here with our edge finder and find the center of the shaft there. All right, tight. So now we'll go ahead and get our edge finder set up. Got my Starrett 1/2-inch diameter edge finder, and I think I got, yep, we got a 1/2-inch collet already in the collet chuck there. And I'm ready to get these guys off my hands. Now for the long journey upwards. I actually have servo motors for both the Y and the Z axis that I have never installed on the mill. It's been a project that I've been wanting to do, and I just never do it. We got to do it though. How nice it would be just to flip a switch and make this knee raise and lower. like giving the Way Lube pump a couple shots whenever we get over here and work on it. All right, I think that's going to be about close enough right there. All right, so we got our 1/2" edge finder in there. We're going to use that to find the center and using our DRO and the half command. So you just start with one side, push the edge finder over, eyeball it about to the center of the shaft, and we'll turn it on and see what my speed is. You don't want to run it too fast. You know, somewhere around 1,000, 1,500 is a good speed. And then this is a visual tool. So that thing's wiggling, and once you get it lined up on that exact edge, this bottom section is going to kick off to the side, just like that. All right, and so that means you're on the edge of that shaft. So we're in our y-axis. We're going to go ahead and just zero that one, push the edge finder over again. We'll go ahead and walk it over here to this side, bring it down. I'm going to line up visually halfway down that shaft, and we're going to repeat the process. You want to come over here so you can see that? Just take it nice and gentle, and you're going to watch for it to kick off right there. Okay. All right, now I'm going to turn this off. Don't let me hit the camera with the spindle here, handle. All right, so if you look up here on the DRO, we have a 1 7/16 shaft, which is 1.4375 nominal, and it's saying that we measured at 1.9366. Remember, we have a 1/2" diameter edge finder, so if you take the 1.4375 and add 0.5 to it, that's what you come up with. Now, according to the DRO, it's 9/10 undersize, which is good. So we're right there where we need to be. All right, so now we take our half command right here, just push half, and then select the axis that you want to split in half. We're going to use the y-axis. That splits it in half exactly. So now we just move the table until we get to 0. Something like that. It's okay if you're a couple tenths off. Now you're in the center of the shaft. Our y-axis is set, and every time we set a shaft in there, we'll be in the very center of it, just like that. So next up, we'll just go ahead and get our cutter installed. Take the edge finder out. I'm gonna put it away. I got this drawer here where I keep my edge finders. And then we're gonna have to change this collet to a 3/8. So let me go find a 3/8 collet. All right, so we're using an ER32. This one's a 1/2. Put this guy back. Need a 3/8. So it's going to be one of these. I'm already using it. These are the Heimer collets here, and my ER32 I only have 3/4, 5/8, and 1/2". So ER25 we go down to 3/8 here. But I should have one in our Technic size, but apparently it is in the machine somewhere being used. I'm just making sure that I don't. Let me check. I got another hiding spot for some collets. Let me check. We got some TMX collets here too. ER32. Here we go. 3/8 collet. That's what we want. I've got a 3/8 high-speed steel 2-flute double-ended end mill. This is what we're going to use. I like using these. This is what I cut my teeth on growing up in the shop. I think that this is a really great tool to use when you're running a manual machine, a manual mill, and you're just cutting some keyways and things like that. Carbide works great, but it's really easy to chip and break it and chatter it. So these are pretty inexpensive tools and they cut a lot of keyways. So we're going to use the high-speed 2-fluter for this. Let me get another wrench, tighten up. We got our Martin ER chuck adapter tools here. That'll be tight enough right there. I'm just checking my notes. 8-inch long keyway on each end. So a quick little easy visual reference. We'll use the DRO, but just go ahead and put your tape up here or your rule and just go ahead and give you a visual representation of where the cut's going to stop. You ready to get started?
Of course.
Okay, I am too. So what I'm going to do, that's about the right speed right there. Pretty good. It's at around 1250 or so. Got that locked. Now what I want to do is establish a flat. So I'm looking at the flat that I'm cutting and I have the reflection of the light there so I can see it really well. And I want to get a full diameter cut on that shaft, and then what I'll do is just hand feed it out like this. And this will get you really, really close. Well, we are just about on the end of that right there. That's as far as I can go. Take your fingernail or your thumbnail, whatever, and just try to catch an edge. So we're gonna go up a couple more thou. There's that illuminator cutting over there. I'm just now starting to feel an edge. I'm gonna go another thousandths. And so I can feel the edge on both sides. That'll put you right where you need to be for adjusting your depth of cut. So now that we have that flat established on here, we're gonna zero out the knee. I'm gonna go up 3/16, which is half of the diameter of the cutter. So 187, we're gonna go, there's one, and then there's 80. But what I'll do, there's 5, 6, 7.5. I'm gonna go a couple thou over that, so we're just gonna take it to 190 thousandths right there. All right, so we should be ready to cut. We're gonna use our mist. I tried to clean the tip, so maybe it'll work a little better today for us. And then what I'm gonna use, let me get by you, and I was gonna show you all what we're running over here on our mister. This is the Master Fluid Solutions trim mist. So this is what I have mixed up in our little tank right there with some water, and that's what we're using as our cutting fluid today. Just trying to get it preset. All right, I think we're ready. I'm gonna touch the end, zero out the DRO on our X, slow this all the way down to nothing. Gauge our feed and bring it in very gently. Now, I don't know what feed I'm running on this manual mill. It's more of a visual thing. I just like to look at this. We have good chips coming off. I don't see this handle like beating and banging because we got a super dull cutter, and it's working great. I do need to adjust that nozzle a little bit. I'm gonna reach in here and see if I can adjust it. See what I mean? When it works great. And that's helping to blow the chips away out of the cut as well. So now we just watch it do its thing. So it's only been a couple of minutes and we're almost down there to the end of it. And that's not a length that's super critical. They just wanted it 8 inches. So you got a little bit of a leeway there. So you can see our black lines coming up close to our cut. I'm looking up on the DRO. We're gonna stop it just a little bit shy. I'm gonna walk it in by hand to 8 inches. I'm gonna back off so it's not rubbing. Stop the mill, turn off the coolant, and now is where I need to check it. So I'm gonna get some gauge blocks and go ahead and check the width of the cut there to see if we're gonna have to offset it one side or the other. So let me get that set up and then we'll check that. This is my stair gauge block set here. I like to just keep this one for the granite plate. These are my other gauge blocks that I consider the shop set. So these are going to come out here and that's what we'll use. I got these at an auction a while back and they work beautifully. All right. So let me do some math in my head and see which ones we want. We want to stack up. We'll start with like 0.374 and see if that's going to measure up right. Let's see, we should have 124 right here. And then we can go with a, do we have a, where's our 250 at? Right here. Here's our 250. It should give us our 374, and we're just going to ring them together. Like so. We got my micrometer here. I can verify it. 374. We'll use this. Let's see if it goes into the slot. It's trying to. It's trying to, but it's a little bit tight. So what I may do, matter of fact, let me reach right behind you here. Let's blow this out. Well, it's not going to be accurate if you're measuring chips. I know. A little bit tight. So I'm going to grab the 123 gauge block. And we'll stack it on here. Even that's trying to be a little bit tight on me. That is trying to go on there. It's a little bit tight. So I think I'm going to have to take a little bit out of those slots there. that's disappointing because I was hoping that we were going to get lucky and just have one cut and be done with it, but you don't always go that way. All right, so that's going in there right there. So according to this gauge block, we're measuring about 372. It's probably around 372 and a half or so. So what I'm going to do to see what we can do to combat that to start with, without moving it off center, we're just going to go ahead and turn the machine back on. We're just going to let it run through there again. And we'll see if that'll clean it up. So that means that cutter's got some wear on it. I've cut a lot of Keyways with that. And to tell you the truth, I need to order some 3/8 end mills. I'm out of new high-speed steel 3/8 end mills that I've been using for this, so I need to get some ordered. I've dug all through my stash and I don't have any more. What we might try is, I've got a 3/8 end mill right here. We've got this Walter 3/8 4-flute. We may put that in there and give that a try because I don't want to fight this this width too much if I can help it. Our drill indexes are ready to be indexed. We've got 2 finished over there. You can see the chips in there, so you're taking a little bit of material out. And that's always a good trick. If you just need to take a little bit out, you can run the cutter back through and let it see if it'll take a few tenths out. I didn't give myself enough room on this end here, so yeah, see, that fell in there that time. But I don't know if we're going to be big enough.
What's this one?
This is going to be 0.373. And yeah, it seems like it's a little tight going in there. If we were at 374, I'd be happy. Trying to go down there, you can see, so it's too tight. So honestly, we need to take a little bit out of that. I think I want to try the other end mill, and we're going to put that in there and see if that will open it up. You know, I want it to be between 0.374 and 375. That'd be a good size on that Keyway. So I know that cutter's got some wear on it, and I think I would rather do that approach versus having to move the table back and forth 1 or 2 thou. One of the beauties, if you're using the CNC mill, it automatically does that for you. Or you can compensate and it'll go around and clean that side up in like 2 seconds. We just got a wore out dull end mill. That's the problem. .372, just like we measured with the gauge blocks there. All right, let's go in with the Walter cutter. I'm just coming up, I know you can't see it, but I'm coming up to where I just touched the bottom. Just starting to touch the bottom there. And tell you what else I'm gonna do. Let me just stop that. I wanna set this to 0 because at the end I'd like to just drop it down, lower it down, and bring it back up to my 0 there. You won't see much, but it will clean up. We're only talking a couple of thousandths, you know. Walking in by hand. Right there. Good. We'll go ahead and inspect that one and see if we got it on size. 373. 374. If you get it square, it usually will go in.
Is it because I'm here?
It's because you're watching and I'm trying to show how simple this is, and it is not going my way today. So apparently that cutter is even cutting slightly undersized. Man, this just ain't right. So I can tell there's a little bit of wiggle in there. You have 1/2 thousandths blocks. I'm just not stacking them in there. This is the actual 3/8 key. And to me, that's fitting pretty nice right there. The 3/8 key. I think we're gonna need to offset it by about 1/2 thou and go ahead and clean that up again, because I'm just worried that it's gonna be a little bit too tight. See, when I go to that, I can't guarantee what size key they're gonna be running in that. That is a good fit. It's going all the way down in the bottom of that. All right, so I went down each side about 1/2 thousandths. This is my 374 gauge block stack up right here. It's fitting nicely. And then here's our key, and you can see it's even fitting nicely as well. So this one is done. And we'll go ahead and we'll get it flipped around and work on the second end there. All right, we're gonna flip this guy around. I'm gonna go ahead and loosen it up. I'm just gonna, for now, I'm gonna slide it down here just where I can reach it a little bit easier. And I'm gonna deburr it using my Noga tool right here. It's a great way to deburr a straight edge like this or a Keyway. Just like that. A little bit more tricky over here, but we'll get it. Just like that. Right there. And I will I'll take a mill smooth file like that and just make sure that there is no other burrs on it, that very end of it. Like that. All right, but other than that, I think we're ready to flip it around. Give the jaws a wipe out here. These look pretty good. I'm gonna give myself a little more room this time to get started on it. So next thing we just want to level that keyway. We're just going to use a simple little bench level to do that, just to align them visually, and that'll be really, really close. So I need to go grab that, and we'll do that next. See, we got our little levels in the stirrup box. How about we use that guy right there? Yep. Pretty close to level right there. So I did find another end mill that I had hidden from myself, and I finally found it. I got this Niagara brand 3/8 two flute cutter. I don't believe, I've never used it. It is razor sharp. So we're gonna try this one and see if this will get the job done. I just don't like 4 flute carbide end mills on the manual mill. I don't know why. Is it just me, or does this affect other people too? But a 4 flute end mill on this manual mill, all the mills I've ever run, it seems like they want to chatter on you. And I had way better luck with 2 flute end mills for all of my keyway cutting over the years. So that's just what that's what I've experienced. But I don't know, maybe I don't feed them correctly. I just know a 2 flute works. I told Abby I gotta get some of those guys ordered. All right, so we're just gonna reset here. Let me go ahead and get my mark put on there. Visual reference for our 8-inch length, and then we'll reestablish our flat there. 1100, that's pretty good. 1100. So what we want to see is our 0.262 times 0.375 times 1100. That's our surface speed, 108 inches. That's our surface speed right there. Not too bad for a high-speed steel cutter going into mild steel. Lock the quill. Just slowly feeding up on it until I see that full circle. Go up a couple of thousandths. I feel the edge now, so we're good. We can go ahead and set us a 0. And we're off the part, so we're going to go up 190. 100. Handle's always right there in the way. There's 190 thousandths. That should be good. Yeah, it's locked there. Okay. We are ready to start our second cut now. Let me get this mist flowing. This doesn't want to stay. I'm always fighting it. I'm just gonna go ahead and send it back the other way and just let it clean up that key. And in case you guys were paying attention and you did notice, I did not set my X the way that I was supposed to. Another reason why it's good to put a visual reference on there. But the length of that, again, is not super critical. You know, when they just tell you make it 8 inches long, there's usually a little bit of extra there, you know. That mister, I'm telling you, it's like, it's either, there is no happy medium. It's either not blowing, or it's blowing too much. It's kind of like traffic. They're either going way too slow or they're trying to blow you off the road. There is no happy medium. That's kind of like that mister right there. When it works great. You really don't need a lot blowing on there, but I'm just trying to make sure that it's coming out, and it is. I did clean it, by the way. All right, we'll give it a check with our gauge block and see where this cutter finished it on our width. That one goes in there. So let me that is 375 right there. Let me grab the let me put the 126 and see where it's at. I wasn't expecting to cut larger than 3/8. I usually don't do that. Well, now I can't get the 376 to go in there, so I think we might be where we need to be. I can't get 376 to go in there. There's our key. Okay, so we did pretty good then. It cut at 375. If I had to, I could fine tune it with some of those tense blocks, but if I had to guess, we're probably 375 and a half on our width right there. So that worked out. That cutter is doing what we want it to do now. We'll just take this out. I'll clean the jaws and then set the second shaft in here. Still a little bit of that grit on here. Make my mark. Eight inches. All right. This time I'll go ahead and touch it off. There we go. I gotta be honest, the performance of that Niagara end mill, it's not doing as good as all of my other cutters usually do. It just doesn't sound the same. Give it a little bit more coolant there.
I did see a comment in the comment section today. They were asking why sometimes you use coolant and sometimes you don't, or you use a little or you use a lot.
That can be, there's variables there on why you do or why you don't. You always want to use coolant anytime you can. If you can't use flood coolant, a mist system like this is the next best thing to do. It's great for open bed mills like this. But generally speaking, the two main benefits of running coolant is to keep your tool and your workpiece cool. The second part is that it lubricates it while it's cutting. I think everybody that does machining, uses cutting oil or some kind of cutting fluid at some time. The flood coolant, the mist, does the same thing. It adds lubricity to the metal, the cutter, to help clear the chip, and prevent the metal from sticking to the cutter while it's cutting. But sometimes when you don't see me using coolant, it's because I'm trying to just see what it is that I'm cutting here, or I don't want to make a big mess. Like for example, if I'm over here on the manual lathe and I'm just doing a simple operation close to the chuck there, and we're spinning any kind of RPM, I'd say over 300, if you run flood coolant, it typically likes to sling out everywhere. It makes a huge mess, and I really don't want to deal with that. So a lot of times you don't see me using coolant over here unless we're doing a drilling operation away from the chuck, or we're doing a long turn on there to where the flood coolant is not splashing over on the chuck. Over here, when I'm doing these keyways and doing this kind of mill, and I like using the mist coolant, if I'm just doing a simple operation where we're just drilling and tapping something, I'd rather use a cutting fluid. That's why I keep this anchor lube around. We like using that. That works really good. That same thing. It's going to lubricate the cut, and it's going to help reduce the heat and the friction from your part and from your cutting tool. It helps prolong the life of your cutting tools, and it helps draw the heat away from everything. Now, over there on the CNC mill, you obviously in production, you really want to use flood coolant all the time, because I don't want to risk, like that aluminum, I don't want to risk it gumming up on the tool and building up on it. It welds to the cutter, and then it just has a catastrophic issue there, We're getting ready to stop it, by the way. 1,000th off. I'm going to go ahead and let it feed back the other way like we did the first time, because it cut it right there on size the way we wanted to. I'm speeding it up now, letting it get through there a little bit faster. But yeah, on the CNC, you really want to flood it all the time to lubricate the cut. That's the big thing with aluminum. It needs that lubricity in there, else the heat builds up and it starts sticking to the cutter, and then that'll lead to a complete fail operation there. Break the cutter off, mess up the workpiece. On steel, if you're machining exotic metals, let's just say stainless, even steel, you really want the coolant there to flush out all the heat that the tool is generating as it's cutting the material. So again, it's cooling the tool, the cutter, it's cooling the workpiece as well, and the oil that's mixed with the water, the soluble oil, is adding that lubricity that you want that helps lubricate the cut when the cutter is cutting and shearing that material off. Does that answer your question?
It does.
Does that make a little more sense?
It does.
Well, hopefully that makes sense to the folks that are asking that question. But again, sometimes it's a matter of, I'm trying to get video to share with you guys what we're doing, and coolant just makes a huge mess and it blocks everything. That's why it makes it more difficult on the CNC mill. So if I can avoid the mess, then I'm going to cut it dry, or use some kind of cutting fluid there. Especially if you're drilling and tapping a hole, you can at least use cutting oil or some kind of cutting fluid to do it. It'll give you the same benefit as flood coolant or the mist there. All right, that one's finished. We'll blow it off and we'll check it with our gauge block, make sure it's good. Abby is getting chips on her new sweatshirt today.
Yes, I am. That's okay.
You do have your work boots on though.
Yes, I do.
And you have your eye
protection
eye shield on, and you have your ear protection in too.
I sure do.
The high pitch of the Miltronics running 10,000 RPM, it does put out a high pitch in the air, and that bothers Abby's ears a little bit.
Yes, it does.
So there's our key stock. It's got a good fit. I just don't like the way the cutter's just not doing a good job. There's our 375 gauge block. So it's good. And as far as the depth goes, I have already checked that. I'm sorry I didn't show that on video, but I've already measured the depth of it, and we're about 5 thou deeper than what the spec calls out for on the depth of the key, but we're where we need to be on our depth. So we're good to go. We're gonna clean this off, flip it around, repeat it one more time. Okay, rinse and repeat, ready to go. Let's see if I can get this mister ready to go.
Maybe.
All right. There's my favorite cut right there. Sorry, just admiring that real quick. That's that illuminator. You hear that? It's like bass. It puts out so much sound, it's like bass vibrating through the air. I like it. DRO set. Getting ready to mill that other hat off in a second. So that's what we have left on our next 100. Here we go. Track the movements here. Isn't that cool?
Very cool.
Yeah, so that's what we got left of our next 100. Those are all finished right there. And we've got 48 of them boxed up right there. They're waiting on UPS to pick them up today. Those are gonna go up to anodizing, and that's the next ones in line for anodizing. We're gonna go with purple this time. Those 48 are gonna be purple. And I think these 48 here, maybe we'll do red again. That seemed to be really popular. I've been enjoying keeping that machine running through this next batch right here while I've been busy out here in the shop. But we're getting pretty close to having that one finished up. I've got some other machining projects that I've been kind of sandbagging on. It's stuff that hadn't been in a hurry or anything to get done. So I've been working on other projects, but we do have a really cool CNC lathe job to do. I need to get to that. I've actually got several parts that I need to work on. And then I still got some manual stuff that I need to get on for my motorcycle buddy, Tim. That I need to jump on. He's been patiently waiting for a few months on that. But those kind of projects, you know, if people aren't in a hurry for it, usually they'll tell me like, hey, I don't need that for like another year. I like to just kind of fit them in when it makes sense for me, you know, get some of this other stuff done that is a little more prioritized on time, and then get to those other projects. But I think some of that stuff is what some folks are excited to see too. This order came through on Friday afternoon. from the fab shop. And I ordered the material yesterday from Alro, and it delivered this morning first thing, about 7:15. They showed up with it. So we're just getting it knocked out because I know they're going to be wanting it back right away. So we're just getting these out of our way, and we can focus on the next project. All right, last time I was within 1 thou. Oh, I went past it. Where did I go? 7.5 thou past it. It's okay. Just gonna let the cutter run back through there. It seems to be cleaning it up right at that 375.5. By the way, shameless plug here, Abby's awesome little feed and speed chart that's on our website. You can go pick you up one. It's just a nice little handy chart to have around when you're wanting to calculate some feeds and speeds. I have tried my best to memorize all that in my head, and that's why I have it on a chart, because I can't always remember that formula at the exact moment that I need to know it. But it's great too, just to have around when you guys are on a manual machine like this, whether it be a lathe or a mill, and you got it spinning. You're like, okay, well, what is the surface speed? Well, there's the formula right there, so you can see what your surface speed is. Like if you have a cutter and you know that it needs to run 100 or 200 surface speed, you can quickly calculate what the RPM is that you need to run by looking at Abby's feed and speed chart. Pick you one up, put them up on the machine or on your crane like that, or wherever it makes sense.
That was the very first project I ever did for you.
Yep. Yeah, she made that for me a long time ago.
Yep.
And then she remade it, and it looks really nice. And I believe, didn't you have a suggestion to make it as a mouse pad?
I did, and I already made it. So I just have to put it up on the store.
Okay, so that one's coming up too, as the mouse pad.
Because I thought that was a good idea.
It is. So a lot of times you're at your computer doing stuff, and it'd be nice to have it just right there under your mouse. All right, so this one's, let me inspect it, make sure that it's on size too. .375 gauge block. Come on, don't make me look like a fool now. There it is. Okay. It's good. That is just slightly tighter than the last one. I think what we have now is you have a few tenths breakdown on that cutter since we started. It was brand spanking new. And here's our standard 3/8 key right there. Good to go. Yep. So really all that's left is just deburring them. And that's next in line. We'll go ahead and get them cleaned up. That's about it for this job here. I'm gonna go ahead and take our cutter out since we're finished with it. You got some chips over here.
I do. I'll get them swept up.
You will?
Yep.
Well, I would certainly appreciate the help with that.
I know you would.
Abby's been enjoying taking video today. We thought that this might be a fun way to capture some content going forward too, where instead of just me getting all the shots, a lot of times that I set up right here on the mill or the machine. This was just a little different style that we wanted to try. Just to have a little fun. She's been wanting to come out here in the shop and spend a little bit more time out here just helping do things instead of sitting at the computer all day long. And so I asked her, would you like to come and help me get a video for milling the keys in these shafts here? And she said, yeah, I'd love that.
Yes, I do. There are many days where I feel like I could do this job, and there are many days where I feel like, no way. It's a lot.
Are you intimidated by this?
Very, yeah.
The cool thing about, you've been hanging around me for a while now around the shop, so you've learned a lot of things.
I have.
it may not be things that you come out and applied with your own hands on a machine or a project, but you're understanding the fundamentals of what it is that you do in a machine shop, and you understand what the cutters are and the tools.
Yes.
You know, and I love that. We just got to get you out here on the machine. I got to show you more hands-on of light and let you run the machine. All right, I think I'll come down here and deburr this one here. Well, that's going to wrap this job up. 2 shafts, cut the link, Keyways milled in it. That's a pretty simple one right there. This was a pretty easy job, but we got her done, and we were happy to share it with you and show my little process on some of the ways to get this kind of stuff done around here. Now, we're not done yet, because now you got to clean the mill up. You got to put all the tools away. That's some of that time that goes into the job that some people don't like to admit or talk about, you know. And well, it only took you 5 minutes to make that cut. Why are you charging me an hour for it? Well, it all adds up, you know, the amount of time. But anyway, did you enjoy filming the? Very
much. You did? I learned something every time.
Yeah. Well, I enjoy having Abby out here helping me, and she's been trying to help out more and more all the time with video making, video editing, capturing video, and all the things that go on in the office and behind the scenes and that kind of stuff. So I always appreciate her help out here.
Thank you, babe.
But we'll let the fab shop know their shavs are ready, and we were glad to share this little job with you this week. And we'll be sure to get the camera out here on all the other stuff that's going on that we have coming up to do as well. All right, so we'll see you on the next video. Got to go clean up the mill now.
I'm going to come sweep.
Are you? You're going to come help? All right. Now we can play Tool.
Exactly. Put it on.
Put the jams on and listen to some music. See you guys later.